All right. At one point, I sounded like Darth Vader. Did I tell you guys that? Yeah, it was really ugly. All right. So if I take a look at 19, 19 said I have 4 times the absolute value of 2k plus 3, and then minus 2 is equal to 6. This is definitely like one I'm going to give you on a test or a quiz. The only variation might be there might be a fraction instead of that 4. All right, the idea is still the same. Okay, so from here, I have to add 2 to each side first. The biggest mistake that I see, 2 big mistakes I see. The first mistake that I typically see, Lily, is that you divide by 4 first. All right, and you forget that you've got to get rid of that subtraction first. That's one of the biggest mistakes I see. The other mistake I see is that people split it now. All right, remember, you can't split it until the absolute value part is completely alone, and you have to solve this just like you would if that was 4k minus 2 equals 6. You've got to get rid of addition or subtraction first. All right, so when I do this, I have 4 times the absolute value of 2k plus 3 is equal to 8. Now I'm going to divide each side by 4. My 4's cancel each other out. This gets the absolute value part alone. 8 divided by 4 is 2. Now I can split this. So I have 2k plus 3 is equal to 2, or 2k plus 3 is equal to negative 2. It doesn't matter the order in which you do that, like which one you do first. All right, so now I'm just going to subtract 3 from both sides. I get 2k is equal to a negative 1. Yep. I'm going to divide by 2. K is equal to a negative 1/2. Or 2k is equal to a negative 5 1/2. Or negative 1 1/2, whichever one you wrote. Who asked me for that? Raphael, does that help you? Awesome. What else can I do for you guys? You guys good? Okay, put this away, get your notes out. So today's the 29th. I want to practice a couple more of these, and then I'm going to talk about when you would use something like this, okay? All right, so this is still 5.5. So 5.5 continued. And I want to solve absolute value equations. Alright, so I want you guys to solve the absolute value of 3x plus 5 plus 6 is equal to negative 2. Solve that, please. Someone tell me what to do from here. Carmen? Okay. Yeah, this is a no solution. How many of you guys noticed that it's a no solution? Awesome. Why is it a no solution? Ashley, why is it a no solution? Yeah, the answer to the absolute value is negative, right? So you can't have a negative absolute value. So no matter what number I put in for that x, it's never going to give me, when I take the absolute value of that work, it's never going to give me a negative 8, because the answer to an absolute value can never be a negative 8, or a negative number. So let's write that down. All right, this is no solution I'm going to say because the answer to an absolute value cannot be negative. Why? Why can the answer to an absolute value never be negative? Right? Yeah, you can't have a negative distance. Remember, because absolute value is a negative is distance. I'm going to say cannot have a negative distance from 0. We can go backwards, but that's not a negative distance. I suppose if you're like doing quantum physics, you could do negative distances. Like I'm sure somewhere out there in like really smart person land with math and science, you could have that. But in our realm here, you're not going to have a negative distance. Okay? Okay. Let's talk about applying absolute values. All right, I'm going to flip. Who needs to see what's up there? Okay. So let's talk about applying absolute values. All right. So there is something called, okay, so do you guys have a bike? How many of you guys have a bike? Okay. How many of you guys at the end of, like when the spring starts and you gotta go ride your bike, what's one of the things you have to do? It's one of the things you have to do, most likely. Really? Pump up the tires. How many of you guys have ever checked the air in your tires? Have you guys ever checked the air in your tires? How many of you guys have ever checked the air or seen how to, like, looked at checking the air in the tires in your parents' car? Okay. What do you do when you're checking the tires? Particularly in a car. You probably don't do this on a bike because you probably don't really care. But in a car, you do. What's one of the things you look at when you're checking the air, when you're checking the tires, and what you've got to do on that? Maya? You gotta look at the air pressure. Have you guys ever looked at the side of a tire? What does it have on the side of a tire? They have this on bikes too. I'm pretty sure they have some bikes. I might be making that up, but I think they have it on bikes. What do they for sure have on car tires? Al? They do. What else do they have on the side of a tire? Joseph? Do you have an ear on the side of your ear? Isn't the tire and the wheel the same thing?
No, I mean,
I didn't say inside. I said on. Okay. Rafaela? They do. They have a number that's air pressure. So they give you on there, and air pressure is in PSI, pounds per square inch. So they'll give you a measurement that's on there, okay? If you were to look in your manual, they have this for basketballs, football, any ball that you have to blow up, basketball, football, soccer ball. If you look in the regulations, you will see in the entire manual, like the manual for your car, you probably see the same thing. You will see a maximum and a minimum pressure, particularly in a sporting event with the soccer ball or football. You have a maximum minimum that you're allowed to have that pressure within. Do you guys ever know that? How many of you guys play a sport where you have a ball that you have to blow up? Okay. How many of you guys remember the Super Bowl many years ago with Peyton Manning? Right? What was the problem there? What was the issue in that Super Bowl? Who remembers?
The ball wasn't inflated enough.
It was not inflated enough. Why? Like why did they deflate it?
So they could catch it.
It was just cold, right? So they could catch it easier. In football, there is a maximum minimum that those refs, every time the ball comes off the field, you've got a ref, or every couple plays, you've got a ref testing the pressure in there, all right? Because there's a maximum and minimum that it can be, all right? There's some, and that is, and what's on your tire on your car is the ideal pressure they want your car tire to be. So I think you'll probably look in there and the price is 36 psi. right? So there's something called an ideal air pressure, right? And then there's something called an acceptable variance. It can vary by 2 psi either way. All right, how many of you guys have mechanical pencils? Okay, so you've got the little, you've got the part that you put the lead in. There's an acceptable variation of a diameter. There's an ideal diameter for a 0.7 lead, but it's physically impossible, really it is, even with computers, for you to have exactly that 0.7 millimeters. So there's an acceptable deviation of that. It can be within probably, and I'm making this up, it could be like 0.05 millimeters smaller or 0.05 millimeters bigger to still be able to fit in this and be able to work, okay? Those are called absolute deviations, and that's what we're talking about here. That's where we have this absolute value stuff, all right? So there's something called an absolute deviation. All right, so what this is a value that an ideal measurement can vary by. All right, so it's a value that an ideal measurement can vary by. All right, and we use absolute deviation equations to figure out what is the maximum and the minimum you can have. All right, so what we can use is we have something, so absolute deviation another word for this is absolute error. That's another word for is absolute error. In your book, they kind of go between the two of them. So the absolute deviation, this is, sometimes I'll say varies by, not by varies, hello. Sometimes I'll use the word varies by instead of absolute deviation because this is what it can vary by, is equal to our actual measure minus the ideal measure. That is the equation for absolute deviation or absolute error. All right, so what I want to do is I want you guys to take a look at this. We're going to write this down. And it talks about absolute error in here. All right, so this is one of those examples of an MBA game. All right, so write this problem down, please. This is example number 5 on page 334. Now, there's many ways that you can do this. This is not the only way that you can find this, but this is, I need you guys to understand how you can use this absolute value stuff. All right, so we want to find the minimum and maximum acceptable air pressures of the ball. All right, so when I take a look at this, that absolute error, that is your absolute deviation. That's your varies by. What that means is that the pressure can be 0.5 psi higher or lower than the ideal. That's what that means. That varies by. All right, so you can very easily just add and subtract that from it, but I want us to be able to use the absolute deviation equation. All right, so let's use our equation. So the equation is, we have our absolute, and again, I'm going to write error only because that's what they called it, but it's the same thing as absolute deviation, is equal to our actual PSI minus the ideal PSI. Your actual, 99% of the time, that actual is what's missing. All right, so I'm just going to substitute in. What is my absolute error here? What is my absolute error? Rita? So there's my 0.5 is equal to, well, the absolute value of my actual minus, what's my ideal? Really? 8. All of you solve that, please. All right, somebody solve this for me. I'll go ahead. All right, keep going. Yeah, PSI, that's right. There you go. So there are my max and my minimum. It's literally the same formula every time. There's no change to that formula. You guys cool with that? All right, let me give you guys another one. Let's see what my handy dandy. Do you guys want a B or a C? Oh my, Rita. Diving right in. Should I start with a B? Should we start with a B? Okay.
I think a B.
Okay, so I want you guys to do number 27 here. This is a B. I know, right? So all of you do this, please. And again, we would explain our answer. Like I just didn't put a sentence to it, we put that in sentence form. How many of you guys eat cereal? That varies by. Because if it says there's 24 ounces in there, there's not exactly 24 ounces. There's an acceptable variation. And they have quality control, people that will just randomly just go pull boxes to make sure that the weight is what the weight is supposed to be. Same thing with, if you get a bottle of water or a bottle of pop. If it's a 2 liter, if you do it, it might not be exactly 2 liters. But there's an acceptable variation. Yes.
They're saying it's $50 off like tubes, right?
You have a coupon for 50 cents off 2 tubes of toothpaste. So my guess is that you have to buy 2 tubes to get the 50% off. Are you good with that? Oh, did you? Good, I figured you would be. Giselle, I forgot I already had that. Oh, that's you. All right. Did you see my text? No? Oh, this one.
Teachers and students, please pardon the interruption. We have Julia Vachon, Isabella Donapodi, and Andrew Nager to do some announcements for us today. Here's Julia Vachon. Great job, Julia. Here's Isabella.
We have an exciting day planned for tomorrow as students may add crazy hats, ties, socks, and slippers to their uniforms. But please remember, no hair dye. Then in the afternoon, we'll have a high-energy pep rally and basketball contest involving students and staff members.
Here's Andrew.
Good afternoon. Before beginning the technical school garden activity, please enjoy those experienced practicing and for further practice.
Sucked into it.
Good job, Julia. Good job, Isabella. Good job, Andrew. Congratulations to our 4th grade basketball team, WIT basketball team. as they defeated St. Karen's. The score was tied 23-23 as Freddie Abdu made a free throw, literally with 0.0 seconds on the clock as he got fouled at the buzzer. Good job to our 4th grade boys basketball team. Happy birthday today to Jackie Slivka. Happy birthday today, Jackie. At this time, could we recycle, as we do have some other activities on Thursday and Friday this week, so those students that typically do our recycling, please recycle now. Please get all the main offices and everywhere that the recycle bins are at. Students, you may have noticed that there are several items out in the lost and found. We will be donating those items this Friday. We would hate to see some of those items go to waste, or if they belong to you, they're not going to go to waste as they'll be donated. However, if they belong to you, please take them. Those are your announcements for this Wednesday. Have a wonderful rest of your Wednesday. Thank you so much.
Okay. Somebody write my absolute value problem. All right, Ashley, go ahead. Excellent. Go ahead and solve that. So if I write this as an answer, I would say, I would write it as a sentence. I'm not going to do that because I know we're running out of time. So this would be our maximum. I don't have one. Thank you. And this would be our minimum. Thank you. And we'd write that as a sentence. You guys know that. Okay. Awesome. So that was part A and B. Somebody tell me, what am I going to do for C? Rafaela? Minus the coupon? How many of you guys agree with that? Awesome. All right, go ahead and tell me what I'm going to do. $0.5. Oh, that's the coupon. Yep. Go ahead. What's the final? So $4.18. How many of you guys got $4.18? Awesome. All right, and again, you'd put that into a sentence. You guys with me? Okay. Let us, okay, this one is just having you guys write the absolute deviation problem. You know when it's in a C that it's not really all that straightforward. So this is a C. This is not one I would give you on a test. The last one is one I would give you on a test. This one is not one. This is just to challenge you. So see what you can do with this. Okay? What'd you say? Dude, just do it. Just do it. just wait, just kind of like hang for the next 5 minutes and just kind of listen, or you can have them explain to you what we're doing. Yes. I did check in. Did I check it in? Did I walk around and check it in?
Yeah.
Yeah, you can. Yeah, we did. I can't remember what I did from moment to moment. I said check yours. It's okay. I'm with you. We're all good. Thank you. So you guys, what is missing from this? What is missing? No, not everything. You've got information, mister, I want to see. What's missing from this? Maggie? The ideal is missing. That is missing. What else is missing? What else is missing? L? Yep, the varies by is missing. Okay. So let's go back to this last one that we did, or any of them that we've done. What do we know about the ideal as it relates to the maximum and the minimum? So think about what the varies by means. So if I gave you the ideal, what's the relationship between the ideal and the maximum and the minimum? Ryan? It is in between the maximum and minimum. Anywhere in between? It's right in the middle. So isn't our ideal dead center in the middle between the maximum and the minimum? Right? So couldn't I come up with can't I use what I have here to come up with the ideal? Right? So I could take the halfway in between. So I could take my 45 plus my 20 and I could divide it by 2. Won't that give me the dead center right in the middle? That average, won't that give me in the middle? Or I could take 45 minus 20 and divide it by 2, and that gives me my varies by. Right? So I could do either one of those. All right, so if I know the max and the minimum, I could take the average of them, because that's right in the middle. So if I divide that by 2, my right in the middle is my ideal of 32.5 minutes. So there is our ideal. Well, how could I find my varies by if I know my ideal? How can I find my varies by if I know my ideal, I know my maximum, and I know my minimum? How can I find my varies by? Seamus? Yeah, I could just, I only need one of them, right? Because if it's dead center, the distance, the difference between the 45 and the 32 should be the same difference between the 25 and the 32.5. All right, so I'm going to do my varies by my 40 minus that 32.5. And that should be 7.5. I'm going to add 7.5 to 20 just to make sure. And no, that's not right. 45. Let's think about that for a second. I need to come up with the middle. How do I come up with the middle? Am I thinking the wrong way to come up with the middle? Thank you. That totally threw me off because that did not give me what I wanted. So let's try that again. 45 minus 32.5 is going to give me 27.5. That makes a big difference. If I add that, is that right? I still did it wrong, didn't I? Thank you. 12.5. Thank you, guys. I'm losing my mind with my calculator. All right, so I have 45 minus 32.5, right? Gives me 12.5. If I add that to my 20, I should get my ideal. So now I have the two values I need to set up my inequality, or my absolute deviation. All right, so I have my varies by is equal to my actual time minus my ideal time. And now I just substitute that in. My actual time is the t. So I would have 12.5 is equal to the absolute value of t minus 32.5. So that was a little bit different. All right, it made you think about what are the things that you need to write that problem and how do I get them from what I have. Yeah. What did I say? What did we say? T is in seconds. So then we'd have to convert that. Yep, so when we're done, we'll convert that. You guys cool? Okay, do you have the idea of what we're talking about? Awesome, okay. Again, I'm not giving that to you on a test.